Welcome to Fundamentals of Chemistry. I'm Dr. Sujatha Krishnaswamy. Today we're going to look at different types or forms of energy. There are two major forms of energy. One is called potential energy, the other is called kinetic energy. Potential energy is energy stored within an object. It could be us or it could be a chemical, and it results from what we are made up of. For example, how is energy stored within us? It is stored in the chemicals inside our body. If you take an object, it is made up of matter, and the energy stored inside the matter is known as potential energy. Kinetic energy is the energy that results as a result of movement. So if you have, for example, if you have the car parked in a parking lot, the energy in the car is potential energy. Whereas when the car starts moving and it's at 70 miles an hour or whatever, the freeway, that energy is kinetic energy. So in essence, potential energy is from position, what the object is made up of, and kinetic energy is a result of motion. Here are two pictures, one in which the car is on top of a hill and it's not moving, so all the energy contained in the car is a result of potential energy. And here we have a runner who is running at full pace, and all the energy he has is now kinetic energy. So a really good example of conversion of potential and kinetic energy is a roller coaster or a car that is parked in the parking lot. For example, a roller coaster, when it's at the highest point, all it has is the potential energy, because it still hasn't moved at full speed, and when it comes down it gains speed, and the potential energy is converted into kinetic energy. So at the end of it all, the total sum is always going to be the same. In other words, kinetic and potential energy can interconvert from one to another, but it can never be created or destroyed. Another good example, as I mentioned earlier, is the car in the parking lot. So all the energy that's contained in the car is potential energy. When it starts moving, some of the potential energy gets converted into kinetic energy. When it's gained enough speed, at that time, all the potential energy is converted into kinetic energy, and when the car slows down and you park it again, the kinetic becomes potential energy. How does this all relate to matter? So we know we have three states of matter: solids, liquids, and gases. The kinetic energy, being the energy associated with the movement, is going to define how much is present in each type of matter. For example, there's unrestricted movement in gases. So there's great velocity or speed for the molecules in the gases, and therefore the energy of the particles in the gas is kinetic energy. Whereas in liquid, there is some movement, so the kinetic energy is present, but it's definitely less than that of a gas. In a solid, there's no movement, the particles are in rigid, fixed position, so all it has is potential energy and no kinetic energy. So if you take a solid and melt it, some of the potential energy is going to get converted to kinetic, and the liquid becomes a gas. A lot of that energy is going to be converted into kinetic energy. Just like the law of conservation of matter, we have the law of conservation of energy. Law of conservation of matter states that matter can neither be created nor destroyed. It can be converted from one form to another. For example, you could convert it from a solid to a liquid to a gas. Similarly, law of conservation of energy states that you cannot create energy, you can destroy it, you can only convert it from one form to another. Potential and kinetic energies are considered as main forms of matter, but you can further subdivide them into heat, light, electrical, mechanical, chemical, and nuclear. These forms of energy can interconvert between each other. Here's a nice example where you see a portable refrigerator on top of a camel. So here there's a solar panel, so the solar energy is converted into electrical energy and keeps the drinks really cold during the travel across a desert. So it's an example of conversion of solar energy into electrical energy. Similarly, we have other conversions as well, which is given on the right side of the slide. For example, the gasoline that you fill into the car is chemical energy. It comes from the chemicals and then it's converted into mechanical energy, which drives the car forward. So mass and energy are very much related because they can be converted from one form to another. So in other words, some of the mass can be converted into energy and vice versa. And this was formulated by Albert Einstein and given in the form of an equation called E equals mc squared, where E stands for energy, m stands for mass, and c stands for the speed of light. So here there's a relationship between E and m, which tells you that mass and energy can be interconverted. But at the end of this process, this physical or chemical change, the total mass and the energy is a constant. So you might destroy some of the mass, but you'll be converting it into energy, and you might create some mass, but that's a result of destroying some energy. At the end of it, the total mass and energy is always a constant. Thank you for joining us today. I hope to see you again soon.